Hello everyone. In the previous videos, we have covered the chapter chemical reactions and equations, acid, bases, and salts. And today we are going to solve some of the important questions on acids, bases, and salts. Okay, without delay, let's get started. Yes, first let us solve the MCQs, that is 1 mark questions. Let me read the first question. When carbon dioxide gas is passed through the lime water, it turns milky. The milkiness is due to the formation of. We know that when carbon dioxide gas is passed through the lime water, the reaction that takes place is this is lime water. When carbon dioxide gas is passed through this, there is a formation of calcium carbonate. This calcium carbonate is white precipitate. It is insoluble in water because of which the lime water will turn milky. So the correct answer is calcium carbonate. Due to the formation of calcium carbonate only, the lime water has turned milky. Then our next question. It is a very easy question, as you all know. Antacids contain. Antacids are usually taken when there is excess acid in our stomach, that is when we are suffering from acidity. So antacids contain weak base. In order to neutralize the excess acid in our stomach, the antacids are taken. They contain weak base. So our answer is B, that is weak base. Then the next question, which of the following is acidic in nature? Gastric juice, sodium hydroxide solution, lime water, milk of magnesia. We know that gastric juice contains hydrochloric acid, so it is acidic in nature. Then what about sodium hydroxide solution? We all know that it is a strong base. So this is wrong option. Then lime water, it is a calcium hydroxide. It is also base. Then milk of magnesia is nothing but magnesium hydroxide. This is also a base. So our correct option is gastric juice, which contains hydrochloric acid. Okay. The next question is, to protect tooth decay, we are advised to brush our teeth regularly. The nature of the toothpaste commonly used is acidic, basic, neutral, or corrosive. We know that tooth decay is caused when the pH of the mouth decreases. When the pH of the mouth is less than 5.5, it causes tooth decay. So what we have to do? We have to normalize that is we have to neutralize the acid in our mouth. We should maintain the acidity in our mouth. So the toothpaste that we have to use must contain basic substance. That is, it should contain mild base. So our answer will be basic. Okay. Then the next question is, if a few drops of concentrated acid accidentally spills over the hand of a student, what should be done? Our options are wash the hands with saline solution, wash the hands immediately with plenty of water and apply a paste of sodium hydrogen carbonate. After washing the hands with plenty of water, apply sodium hydroxide solution on the hands. Then the next option is neutralize the acid with strong alkali. What happens if concentrated acid accidentally spills over our hand? First, we need to wash our hands immediately with plenty of water. Then what we need to do is we need to apply a mild base on it. Otherwise, if you apply a corrosive basis or very strong basis like sodium hydroxide, again our skin will be affected. So what we need to do? We should apply the mild base on it to neutralize the excess acid there. So our correct option will be wash the hands immediately with plenty of water and apply a paste of sodium hydrogen carbonate. Why? Because sodium hydrogen carbonate is a basic salt. So after applying this, we will get relief. We should never apply sodium hydroxide solution on our hands as it is highly corrosive. And also we should not neutralize the acid with strong alkali as they are corrosive in nature. It will affect our skin. Okay. While solving the questions like this, we have to think practically. We should never think that we should neutralize the acid that has spilled on our hand. No. We should think it practically. As bases are corrosive in nature, we cannot apply directly the corrosive bases, that is very strong bases like sodium hydroxide or potassium hydroxide on our hand. We have to apply mild bases. Even in case like when we are suffering from acidity, we will be taking mild bases like magnesium hydroxide that is contained in antacids. You should remember this. Okay. Then the next question is, 10 ml of solution of sodium hydroxide is found to be completely neutralized by 8 ml of given solution of HCl. If we take 20 ml of the same solution of sodium hydroxide, the amount of HCl solution, the same solution as before, required to neutralize it will be. What has happened here? 10 ml of NaOH is neutralized. It is completely neutralized by 8 ml of given solution of HCl. Okay. So 10 ml is neutralized by 8 ml of given solution of HCl. Then our question is, if we take 20 ml of the same solution of sodium hydroxide, the amount of HCl solution that is required will be. So if we want to neutralize 20 ml of the same solution of NaOH, I have to take here NaOH. Okay, if 20 ml of the same solution of sodium hydroxide is taken, means we have not changed its concentration. The same solution that is taken in another volume. Okay, 20 ml of NaOH is taken, then what amount of HCl will be needed? So it is clear that 10 ml needs 8 ml, means if double the amount is taken, then double the amount of hydrochloric acid is also needed. That is 8 into 2 is equal to 60 ml. If I have doubled this amount, that is 10 ml of NaOH first we had taken. Again now we are taking 20 ml of NaOH, means initially 8 ml of HCl was needed. Then in the second case we should require 16 ml of HCl to neutralize the base completely. Okay. So our answer will be D, 16 ml. Next, the chemical formula of plaster of Paris is, we know that plaster of Paris is calcium sulfate hemihydrate, that is CaSO4 hemihydrate of H2O. So our answer is this one. Option B is the correct answer. So our next question is, when a small amount of acid is added to water, the phenomenon which occur are dilution, neutralization, formation of hydronium ions, salt formation. We know that when acid is added to water, what happens there? There is a formation of ions. The acid will produce H plus ions, which will combine with water to form hydronium ions. Yes, if HCl is dissolved in water, what happens there? There is a formation of hydronium ions and chloride ions there in case of hydrochloric acid. And also again one thing happens. What is that? When we are mixing water in acid, that is acid in water, the process is called as dilution. Yes. So here we can say that the two phenomenon occur. One is dilution and another one is formation of hydronium ions. Yes. First what happens? It will form H plus and Cl minus ions. As H plus ions are unstable, they will combine with H2O. So they will combine with H2O to form H3O plus. Okay, there is a formation of hydronium ions there. So both dilution and formation of hydronium ions takes place there. Then what about option B and D? Neutralization? No. When acid is dissolved in water, neutralization will not take place. Neutralization reaction will take place in presence of base. When acid and base combine together, there is a neutralization reaction. Then what about salt formation? Yes, even salt formation is also occur in the presence of base only. Acid and base combine with each other, that is they react with each other to form salt and water. So these two are wrong. So our correct option will be A and C. Which is the correct option? That is A and C. Okay. Then which of the following salts do not contain water of crystallization? First, we should know the molecular formula of each compound in order to identify which of these is not containing water of crystallization. What is blue vitriol? It is copper sulfate, pentahydrate, CuSO4, 5H2O. It is a formula for blue vitriol. Then what about baking soda? The formula is NaHCO3, sodium bicarbonate. Then what about washing soda? It is sodium carbonate decahydrate, that is 10H2O. What about gypsum? The formula is calcium sulfate, that is CaSO4 to H2O. So the question here is, which of the following salts do not contain water of crystallization? You can see here blue vitriol, washing soda and gypsum all have water of crystallization. So which is that salt that is not having water of crystallization? That is baking soda. So our correct answer will be B, that is baking soda. Next, match the chemical substances given in column A with their appropriate application given in column B. Yes, this is an important question. You should always remember the applications of the salts or the compounds that have given in your syllabus, like baking soda, bleaching powder, washing soda, sodium chloride, etc. So let us see here. Bleaching powder, among these, which is the use of bleaching powder? What is the application of bleaching powder here? It is used in the decolorization. Bleaching powder, it is used in decolorization. Then what about baking soda? You can see here, it is used as an antacid, as it is having the basic character. It is a mild basic salt. Yes. So baking soda is used in antacids. Then what about washing soda? It is used in the preparation of glass. Washing soda. It is used in preparation of glass. Then sodium chloride. As we all know that sodium chloride is used in the preparation of sodium hydroxide, where we will get the byproducts, that is hydrogen and chlorine also. So sodium chloride is also used in the preparation of H2 and Cl2, that is hydrogen and chlorine gas. So which will be our correct option? A3, A3, B4, C1 and D, sodium chloride 2. So this will be our correct option. Okay. Okay, let us move to the next question. You are given three unknown solutions with pH values 6, 8 and 9.5 respectively. Which solution contains the maximum OH minus ions, that is hydroxide ions? Let us take sample 1, sample 2, sample. All these solutions pH values are given. Sample 1 has pH 6 and sample 2 8 and sample 3 9.5. So our question is, which solution is having the maximum OH minus ions? As we all know that as pH value increases from 7 to 14, the concentration of OH minus ions also increases. This means more the pH value, more will be hydroxide ion concentration. So among these, which is having more pH value? That is sample 3 is having more pH value. So more the pH value, more will be the hydroxide ion concentration. So our answer will be B, that is sample 3. Next, the acid produced in our stomach during digestion of food is hydrochloric acid, oxalic acid, lactic acid, acetic acid. It is 100% sure that our stomach produces hydrochloric acid in the gastric juice. Okay. Next, which of the following are electrolytes? Dilute HCl, sugar solution, alcohol in water, lime water. We know that electrolytes are those compounds which produces ions in the solution and conducts electricity. So we know that dilute HCl also forms ions and conduct electricity. Sugar solution, it will not form ions. Alcohol in water, it will not form ions. Then lime water, it will form ions. Lime water means CaOH twice, that is calcium hydroxide. It will form ions in water. So our correct option is 1 and 4. 1 and 4. The correct option is B. Next question. In the neutralization reaction, when excess of acid is added to an alkali, salt and water are produced. What is the nature of the solution after the reaction occurs? First, understand the question properly. In the neutralization reaction, when excess of acid is added to an alkali, okay, when acid and alkali they are mixed, it forms neutralization, means they undergo neutralization reaction. Okay. Then our question is, excess of acid is added. This is added in excess. If they are added in the same amount, means the amount that is required for neutralization reaction, then it would be neutral in nature. But here excess of acid is added to an alkali. What happens? The neutralization reaction that takes place will be resulting in the formation of salt and water, but the solution will be acidic in nature as we are adding excess of acid there. So the resulting solution will be acidic. Okay. Next, it is AR question, that is assertion reason question. Assertion is ammonia is acidic in nature. Reason, ammonia dissolves in water and forms hydroxide ions. You can easily see here assertion is wrong. Ammonia is not acidic in nature. It is basic in nature. When ammonia is dissolved in water, it forms hydroxide ions. So the reason ammonia dissolves in water and forms hydroxide ions is correct. So let us see the option now. Both assertion and reason are correct, and reason is the correct explanation of A. No, assertion is wrong. So option A is also wrong. Both assertion and reason are correct. No, assertion A is wrong. So this option will also be wrong. Assertion is true, but reason is false. It is clear that assertion is not true, so this option will also be wrong. Then assertion is false, but reason is true. Yes, it is true that this assertion is wrong, but the reason that ammonia dissolves in water and forms hydroxide ions is, so option D will be correct. When ammonia is dissolved in water, what happens? Ammonium hydroxide is formed. It will produce hydroxide ions. Okay. Let us read the next question. It is a case study question. Read the passage carefully and answer the following questions. A compound C of sodium forms a white powder. It is a constituent of baking powder and is used in some antacid. When heated, it gives a compound D which is anhydrous and absorbs water to become hydrated salts. When this salt is kept in the open air, it loses water molecules in a process called efflorescence. When dissolved in water, it forms a strong base and a weak acid F. First of all, you have to read the question properly. You have to understand it before going to attempt the questions. Okay. Let me solve step by step. A compound C of sodium forms a white powder. What is C here? C is compound of sodium. Again, what hint they have given is it is a constituent of baking powder. What is C? It is constituent of baking powder. So, by seeing this only we can understand the constituent of baking powder is sodium hydrogen carbonate, that is sodium bicarbonate, and it is also white in color they have given, and also it is mentioned that it is used in some antacids. Then it is 100% sure that it is used in antacids, so the compound C will be sodium bicarbonate. Then which of the following is compound C? The question is we have to find out the C. Then from this only it is clear that the compound C is sodium hydrogen carbonate or sodium bicarbonate. Then the next question of this passage is which of the following is compound D? They have given that when compound C is heated, it gives a compound D, that is anhydrous, and it absorbs water to become a hydrated salt. Okay. When this compound C is heated, what they have given, it forms a compound D, that is anhydrous. We know that when sodium bicarbonate is heated, we get sodium carbonate, water and carbon dioxide. Okay. And they have also given it is anhydrous. Yes, it is anhydrous. And when it absorbs the water molecules in the crystal structure, it forms sodium carbonate decahydrate, that is washing soda. So the compound D will be sodium carbonate only. Okay, you should not write sodium carbonate decahydrate. Okay, it is anhydrous. After heating sodium bicarbonate, we will get sodium carbonate. So the compound D will be sodium carbonate, that is Na2CO3. Then again they have given that when this salt is kept in the open air, it loses water molecules in a process called efflorescence. When it is dissolved in water, it forms a strong and a weak acid F. Okay, and they have given that when this sodium carbonate, that is D, it is dissolved in water, it forms a strong acid and a weak base. So when sodium carbonate is dissolved in water, it forms strong base sodium hydroxide and weak acid, that is carbonic acid. This sodium carbonate is formed by the combination, that is neutralization of strong base sodium hydroxide and weak acid carbonic acid. So what is the nature of the solution formed by dissolving D in water? D here is sodium carbonate. When this is dissolved in water, the resulting solution will be alkaline, as this sodium hydroxide is strong. It is a strong base. So the resulting solution will be alkaline. So our answer will be B. So have you understand? How is it? The nature of the solution, D is the nature of the solution formed by dissolving D in water is alkaline because it is having the strong base here, because of which the solution will be alkaline in nature. And also they have given it forms a strong base and a weak acid F. Yes, when sodium carbonate is dissolved in water, it forms strong base, that is sodium hydroxide, and weak acid carbonic acid. Okay. So a weak acid is F. In the next question, they have asked which among the following is compound F. Compound F is weak acid, that is carbonic acid. This is the correct answer. Then sodium carbonate is a basic compound because it is a salt of. How sodium carbonate is formed? It is formed by the neutralization of sodium hydroxide and carbonic acid. It forms, yes. This sodium carbonate is formed by strong base and weak acid. Carbonic acid is weak acid as it partially ionizes in water to form H plus ions. So the resulting salt will be basic in nature. The answer is it is a salt of strong base and weak acid. That is the strong base and weak acid. Next, illustrate an activity to investigate whether all compounds containing hydrogen are. We have also seen in the NCERT activity itself that all the compounds that are having hydrogen are not acidic in nature. But we have to illustrate an example or activity here also. What can we do? We should take two beakers. In one beaker, we can take any acid like hydrochloric acid or sulfuric acid. In another beaker, we have to take either alcohol or glucose solution. Then we have to make the circuit by connecting the terminals to the battery and connecting the bulb in those two separate beakers. The circuit in which the current is flowing will cause to glow the bulb. In the circuit where it is not complete and electric current is not passing, there the bulb will not glow. Let us write it. Okay. Take two beakers separately. In them take solutions of HCl, that is hydrochloric acid, and glucose. Then in each solution take two nails fixed on a rubber cork and connect the nails to the terminals of the battery and bulb. Okay, we have made the electrical connections using the two solutions separately there. When the electric current is passed, the bulb in the circuit containing HCl glows, whereas the bulb in the circuit containing glucose will not glow. This shows that hydrochloric acid has produced H plus and Cl minus ions and conducts electricity, whereas the glucose solution has not produced ions. So our answer will be all the compounds containing hydrogen are not acidic. Only those solutions which produce H plus ions on dissolving it in water will be acidic in nature. Okay. So all compounds containing hydrogen are not acidic. We know that even glucose has hydrogen atoms. It has also hydrogen atoms, but these hydrogen atoms are not ionized. Means this glucose solution will not produce ions, because of which it will not behave as acid. It is not having acidic character. Okay. So how we have checked this? We have to take the two beakers separately and we have to take the solutions of HCl and glucose. Why we have taken glucose? We want to show that even those containing hydrogen atoms may not be acids there. So we have taken glucose, and then in each solution take two nails fixed on a rubber cork and connect the nails to the terminals of battery and bulb. Okay, so that circuit is complete. When the electric current is passed, the bulb in the circuit containing HCl glows because there the solution is conducting electricity because of formation of ions, whereas the bulb in the circuit containing glucose will not glow because glucose has not formed any ions. So the circuit is not complete there and the bulb will not glow. This shows that HCl has produced H plus and Cl minus ions and conducts electricity, whereas the glucose solution has not produced ions, so all compounds containing hydrogen are not acidic. Only those compounds which forms H plus ions are acidic. Okay, understood? Then the next question is, a compound P forms the enamel of the teeth. It is the hardest substance of the body. It does not dissolve in water but gets corroded when the pH is lowered below 5.5. We have to identify the compound P. Okay, we know that our tooth enamel is made up of the hardest substance, that is calcium phosphate. The answer is calcium phosphate. Then how does it undergo damage due to eating chocolate and sweets? What should we do to prevent the tooth decay? So even though it is the hardest substance, how does it get damaged? Yes, when sweets and chocolates are eaten, the particles are stuck in the mouth. Yes, the particles are stuck in the mouth. Those particles are degraded, means they undergo degradation by the bacteria present in the mouth. By the bacteria present in the mouth. Those bacteria, while degradation of the particles, release acid in the mouth. What they do? They release acid in the mouth. This acid corrodes the tooth enamel. So how it has happened? When the particles of the food that we eat, or the chocolates, the sweets that we eat, are stuck in the mouth, there are bacteria present in the mouth. Those bacteria will act on the particles and cause them the degradation by releasing acids in the mouth. When the acids are released in the mouth, the pH of the mouth will decreases, because of which that acid will corrodes the tooth enamel, causing the tooth decay. Then we have to answer that what should we do to prevent the tooth decay. Here we have answered the compound P is calcium phosphate. Then we have also answered that how does it undergo damage due to eating chocolates and sweet. Now there is still one more question. What should we do to prevent the tooth decay? To prevent tooth decay, we have to wash the mouth after every meal. We have to clean the mouth. And also, we can use the toothpaste that are basic in nature, so that it will neutralize the acid that is released in our mouth. To prevent tooth decay, what we have to do? Wash the mouth properly after every meal and use toothpaste that has mild base. Okay, so that it will neutralize the acid of the mouth. Nowadays, mouthwash is also given by the dentist. What it contains? That mouthwash also contains the mild bases, so that it will neutralize the excess acid in the mouth. When the when the acid character in the mouth increases and it goes, that is pH, when it goes below 5.5, the tooth decay is caused. Okay, this is how we can prevent the tooth decay. Next, sodium hydrogen carbonate is a basic salt. Justify this statement and how is it converted into washing soda. How sodium hydrogen carbonate is formed? It is formed by the neutralization reaction of sodium hydroxide and carbonic acid. So it is formed by the strong base and weak acid. Yes, this is formed by the neutralization of strong base and weak acid, because of which this sodium hydrogen carbonate is a weak, that is basic salt. It is, we know that when the salt is formed between the strong base and weak acid, it will be basic in nature. It is formed by strong base and weak acid. If the salt is formed between the strong acid and strong base, then the salt will be neutral in nature. If it is formed by the strong acid and weak base, then the resulting salt will be acidic in nature. Okay. And they have also given how is it converted into washing soda. It is prepared by heating sodium hydrogen carbonate. When sodium hydrogen carbonate is heated, sodium carbonate is formed. When it is heated, it forms sodium carbonate. So when sodium bicarbonate is heated, sodium carbonate is formed. What is the washing soda? It is obtained by recrystallization of sodium carbonate. Okay. recrystallization of sodium carbonate gives washing soda. What is recrystallization? When this sodium carbonate is dissolved in water and it is left for some time, what happens? There is a formation of crystals, and also the water molecules are absorbed in this crystal structure to form this washing soda. This is called as water of crystallization. It is a fixed number of water molecules present per formula unit of the salt. Okay, these molecules are present in the crystal structure. Do not get confused. Baking soda is different and washing soda is different. It is washing soda. You should remember the molecular formula, and this is sodium carbonate. You should remember the names and also chemical formula. Overall, how we have got washing soda from baking soda? That is, it is baking soda. When it is heated, we get anhydrous sodium carbonate. It has not any water of crystallization. And when it is recrystallized from the solution, we will separate the crystal of this salt, that is washing soda. So finally, the recrystallization of sodium carbonate gives washing soda. This is how you have to write the preparation. You have to read the whole question properly and then answer. The first question is sodium hydrogen carbonate is a basic salt. Justify this statement. We have to justify how it is formed by the neutralization reaction of strong base and weak acid. So it is a basic salt. Then we have to write how is it converted into washing soda. We will form washing soda by heating sodium bicarbonate and then recrystallization it from the solution gives washing soda. Okay. Then the next question is, what is the action of litmus on dry litmus paper? So what happens here? When the litmus paper is held, the next question is, what is the action of litmus on dry HCl and solution of ammonia gas in water? Let us answer the first question. The action of litmus on dry HCl will be, there is no change in the color as there is no formation of ions there. The litmus will show color change only when there is presence of H plus ions. So when the litmus paper is held near dry HCl, there will be no change in the color. So you have to write no change in color of litmus because H plus ions are not produced. Then what is the action of litmus on solution of ammonia gas in water? We know that solution of ammonia gas in water gives hydroxide ions. So they will give OH minus ions. So the red litmus will change to blue color. The second answer will be red litmus changes to, as it produces hydroxide ions which are basic in nature, changes to. So the litmus will changes from red to blue color. Okay, have you understood this answer? Then let us move to the next question. So the question is, a compound X which is prepared from gypsum has the property of hardening when mixed with proper quantity of water. Identify X and write its chemical formula. They have given that X, it is prepared from gypsum, and also they have given that it has the property of hardening when mixed with proper quantity of water. Then it is sure that it is plaster of Paris. X will be plaster of Paris because it is prepared by heating the gypsum at 373 Kelvin. And we have to write the chemical formula. What is the chemical formula of plaster of Paris? It is CaSO4 of H2O. Okay. So let us write. So compound X is plaster of Paris as it is prepared from gypsum. Chemical formula, it is CaSO4 of H2O. It is also called as calcium sulfate hemihydrate as it has half water molecule of crystallization. Means in between two formula units of calcium sulfate, there is one water molecule of crystallization. How it is formed? It is formed by heating gypsum at 373 Kelvin. Then you can also write the reaction, how it has happened. When gypsum is heated at 373 Kelvin, we will get plaster of Paris. This is plaster of Paris. Okay. Then the next question is, this is first question. State the difference in chemical composition between baking soda and baking powder. We know that baking soda is nothing but sodium hydrogen carbonate. It is sodium hydrogen carbonate. Whereas baking powder means it is a mixture of sodium hydrogen carbonate and edible acid like tartaric acid. This is baking powder and this is baking soda. Okay, let's read the next question. What happens when nitric acid is added to eggshell? We know that eggshell is made up of calcium carbonate. Okay, when the nitric acid is added to calcium carbonate, what is the reaction that happens? Let us write calcium carbonate plus HNO3, that is nitric acid. It forms calcium nitrate plus water and carbon dioxide. So our answer will be eggshell contains calcium carbonate. When nitric acid is added to eggshell, carbon dioxide is liberated and calcium nitrate is formed. And you have to write the reaction then. Okay, this is calcium carbonate. When it reacts with nitric acid, calcium nitrate, water and carbon dioxide are formed. Okay, then the next question is, what are strong and weak acids? In the following list of acids, separate strong acids and weak acids. Okay, we know that the strong acids ionize completely in aqueous solution. They ionize completely in aqueous solution, forming hydronium ions. Whereas weak acids ionize partially to form hydronium ions. Means in case of weak acids, what happens? All the molecules are not ionized. Only some molecules are ionized to form hydronium ions. So the aqueous solution of same molar concentration of weak acid has very less number of hydronium ions than that of strong acid. Suppose if I have taken the same molar concentration of the two acids, that is weak acid and strong acid. In strong acids, what happens? All the molecules are ionized and form hydronium ions. Whereas in case of weak acid, what happens? Only part of the molecules, some of the molecules are ionized to form hydronium ions, because of which the same molar concentration of, in both the cases, the amount of hydronium ions will be more in number in case of strong acids. Okay, this is the main difference between strong and weak acids. And among these, we have to separate the strong and weak acids. Okay, let us write strong acids here. Among these, the strong acids are hydrochloric acid, nitric acid is strong acid, sulfuric acid is also strong acid. Okay, hydrochloric acid, nitric acid and sulfuric acid. The other three acids are weak acids, as they do not completely ionize in water. Weak acids: citric acid, formic acid and acetic acid. Yes. So understood? These acids are mineral acids which are strong. So they will completely ionize in water to form the hydronium ions. Whereas these are organic acids which are weak when compared to strong acids. Okay. Next, identify the correct representation of reaction occurring during chlor-alkali process. These are all reactions representing the chlor-alkali process, but we have to identify the correct representation of the reaction. See here, in chlor-alkali process, we will take the aqueous solution of sodium chloride, that is brine. We will take the aqueous solution of sodium chloride. And then what we get sodium hydroxide, chlorine gas and hydrogen gas. So let us see which is the correct option here. Here they have given liquid L, but sodium chloride is aqueous solution. What we have taken is brine, that is aqueous solution of sodium chloride. This will be wrong. Then see here this is also not the correct representation of water. We will write L for it, so this is also wrong. Then see the C option, sodium chloride aqueous. Yes, it is correct. H2OL, it is correct. NaOH, that is aqueous solution. Yes. Here chlorine and hydrogen are representing the aqueous solution, but they are in the form of gas. So this option is also wrong. See the next option here, sodium chloride aqueous, that is correct. Water liquid, sodium hydroxide is aqueous solution. We are getting chlorine and hydrogen gas. So the correct option will be D. So you have to remember the physical states properly when it comes to the important reaction, as this reaction is very important. The chlor-alkali process is very important from the examination point of view. You have to remember the process that is involved in the reaction, and also you should remember the equation, that is balanced chemical equation. Okay, next. Write a balanced equation to show the reaction that occurs when a piece of aluminium is dipped in a dilute solution of sulfuric acid and sodium hydroxide. So can you remember, this is a reaction between metal and acid. What we were going to get when metal and acid were reacted? We get salt and hydrogen gas. So let us take this given example, that is aluminium reacts with sulfuric acid. Okay, let us try to write the reaction here. Aluminium reacts with sulfuric acid, so it forms the salt aluminium sulfate. Okay, this is aluminium sulfate. Then what is the formation? Hydrogen gas is liberated. Okay, this is the equation. Now we have to balance. There are 3 sulfurs here. We have to put here 3. Again, there are 3 twos are 6 hydrogens here. Here also we should get 6 hydrogens. Then aluminium, there are 2 aluminium atoms here. We have to get 2 aluminium here. Now it is a balanced equation. So what happens when aluminium reacts with sulfuric acid? We get aluminium sulfate. You should write the reaction along with the names. Aluminium sulfate, and this is hydrogen, as we all know. So metals react with acids to form salt and hydrogen. So you all know how to write the chemical formula that you have studied in class 9 also. Let me recall it. AlSO4. Okay, aluminium sulfate. The valency of aluminium is 3. Valency of sulfate is 2. So cross multiply. I will get Al2SO4 thrice. Okay, you have to remember the method to write the chemical formulae. Then again the question is asked that reaction of this aluminium with sodium hydroxide. How do metals react with bases? This is about the reaction of metal with base. We know that not all the metals will react with base. You should remember only aluminium and zinc will react with the strong base like sodium hydroxide to form salt and hydrogen gas. So aluminium reacts with sodium hydroxide in the presence of water to form sodium aluminate. Okay, we have to balance the equation. So aluminium will also be 2. Then what about hydrogen? Here there are 2 plus 2 to the 4, 6 hydrogens. So I should get here 6 hydrogens. Okay, this is balanced equation now. It is sodium aluminate. Remember that aluminium reacts with sodium hydroxide in the presence of water to form sodium aluminate and hydrogen. You have to remember the name and chemical formula. Okay. Next, write the color of the solution formed when copper oxide is treated with hydrochloric acid. Give reason for this observation. So, we have to solve this. When copper oxide is made to react with hydrochloric acid, what happens there? There is a formation of salt, that is copper chloride and water. They have asked that write the color of the solution formed when copper oxide is treated with hydrochloric acid. We know that when copper oxide reacts with hydrochloric acid, it forms copper chloride. And the color of the solution is, we know that it is blue-green in color. Copper chloride is blue-green in color. This is a reaction of metal oxides with acid to form salt and water. That is, metal oxide, they behave as bases here. They are basic in nature. Okay. Why this happens? The color of the copper oxide gets changed. Why? Because copper oxide reacts with hydrochloric acid to form copper chloride and water. Because of this, the color of the solution becomes blue-green. Copper oxide is actually black in color. Once it reacts with hydrochloric acid, it forms blue-green solution of copper chloride. Okay. Next, the question is list the important products of chlor-alkali process. Write on important use of each. Okay, we know that in chlor-alkali process, the product formed are, we get sodium hydroxide, we get chlorine gas, and we get hydrogen gas. And here we have to mention the important use of each. We know that sodium hydroxide is used in manufacture of soaps and detergents. Soaps and detergents. You can write only one use of each as they have asked one, detergents. No problem even if you write one or more. What is the use of chlorine gas? It is used in cleaning of the swimming pools. Yes, cleaning of, as it is a germicide, or it is, you can also write, used in water treatment. Then what is the use of hydrogen gas? There are many uses, like it is used in the rocket fuel, and the one more important is it is used in the manufacture of ammonia by Haber's process. Okay, it is used in the manufacture of ammonia. Okay, these are the products of chloralkali process, and these are the one use of each product here. Okay, so we should always remember the commercial benefits of these products like chlorine, hydrogen, sodium hydroxide, and the other products that are obtained from sodium chloride like baking soda, washing soda, etc. Then the next question is, how do metal carbonates and metal hydrogen carbonates react with acids? Taking magnesium as metal, write a balanced chemical equations in both the cases. State the method to test the gas evolved in each in the reactions. We know that when metal carbonates or metal hydrogen carbonates, they react with acids, what they form? They form salt, carbon dioxide and water. Okay, so here we have to write the equation by using magnesium as metal. We have to write the balanced chemical equation here. Let us write the reaction. Magnesium carbonate MgCO3 reacts with hydrochloric acid. It is a acid to form salt, magnesium chloride, and there is a formation of carbon dioxide and water here. This is a metal carbonate, this is acid. When the metal carbonates reacts with acid, they form metal salt and carbon dioxide and water. Okay, we should also write the magnesium hydrogen carbonate, its reaction with hydrochloric acid, as they have asked the both equations. Okay, magnesium hydrogen carbonate, the formula is MgHCO3 twice. Here also salt MgCl2 is formed, carbon dioxide gas is released, and also there is formation of water. Okay, sorry, here we have written gas. Now balance the equation. There are two carbon atoms here. Here also we should get 2. What about oxygen? Here there are 6 oxygen atoms plus 4. Here also we have to get whole 6 oxygen atoms. Now the equation is balanced. Okay. This is the reaction of metal carbonates, that is magnesium carbonate and magnesium hydrogen carbonate with hydrochloric acid to form salt, carbon dioxide and water. Okay. And also they have given that we have to mention the test to test the gas evolved in the reaction. Here you can see clearly that carbon dioxide gas is released. How to test the carbon dioxide gas? We all know that when carbon dioxide gas is passed through the lime water, it will turn lime water milky. Okay. Test for CO2 gas. When CO2 gas is passed through lime water, it turns milky. This is the test for carbon dioxide gas. You can also write the equation for it. This is lime water. When CO2 is passed through it, it forms calcium carbonate. It is white in color, because of which the solution will turn milky. Okay. This is a test for carbon dioxide gas. Now the next question is, 2 ml of sodium hydroxide solution is added to a few pieces of granulated zinc metal taken in a test tube. When the contents are warmed, a gas evolves which is bubbled through a soap solution before testing. Write the equation for the chemical reaction involved and test to detect the gas. Name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. Okay, let us solve this question. 2 ml of sodium hydroxide solution is added to pieces of granulated zinc. So we have to write the reaction for zinc with sodium hydroxide. Okay, zinc reacts with sodium hydroxide. It is a reaction of metal with base. It forms sodium zincate. It is sodium zincate. Here there is a evolution of hydrogen gas here. They have given that a gas evolves which is bubbled through a soap solution before testing. Write the equation for the chemical reaction involved and the test to detect the gas. We have written the chemical reaction here. We have to test the hydrogen gas. Okay, we know that when hydrogen gas is evolved and a burning candle or a matchstick is brought near the gas, it will burn with a pop sound. Okay, when a burning candle or matchstick is brought near the gas, it will burn with pop sound. So we have solved these two. Write the equation for the chemical reaction involved and the test to detect the gas. We have written the chemical equation also. So balance this. Then again they have given that name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. See, it is little bit twisted, but if you understand the concept well, then it is very easier to write. The same metal means here you have to take again the zinc only. When the same metal, that is zinc, reacts with dilute solution of strong acid, you can take strong acids like hydrochloric acid or sulfuric acid. Let us take hydrochloric acid here. What is the formation? When metals react with acids, we get salt ZnCl2 plus H2. Okay. This is the reaction that forms. Again, they have asked that name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. Here also, we should write zinc reacts with hydrochloric acid to form zinc chloride. It is salt and the gas evolved is hydrogen. So you should complete the answer. First check the question properly. What all they have asked you. Okay, in the same question you can see here it is of 3 marks actually. You have to write the equation for the reaction of zinc and base here, that is sodium hydroxide. You should write the complete equation. Then they have given that write the test for gas, for the gas that is evolved. So we have written the test for hydrogen gas here. And also they have asked to write the reaction for the same metal, that is zinc. You have to take the same metal which is mentioned in the question with the dilute solution of strong acid. Strong acid means you can write hydrochloric acid. So it will form again the salt and hydrogen gas. And at last you should mention that which is the gas that is being liberated. That is here hydrogen gas is liberated. You have to mention it. Okay. Read the question properly and answer each and every part of the question without miss. Okay. Next, write the name, method of preparation and uses of following. It is also a very easy question. This is, we know that bleaching powder. Let us write the method of preparation for bleaching powder. We know that it is prepared by, bleaching powder is prepared by the action of chlorine on dry slaked lime. How does this forms? When dry slaked lime is taken and it is made to react with chlorine, we get bleaching powder. This is bleaching powder. And also they have given that we have to write the uses of the following. What is the uses of bleaching powder? It is used as an oxidizing agent. It is used as an oxidizing agent, and also as the name itself indicates, it is used to bleach the cotton and linen textile in the textile industries. Okay, it is used to bleach cotton and linen in textile industry. After bleaching, there is a shining appearance on the cloths. Because of that only the cotton and linen textiles are bleached with bleaching powder. Okay. Again, we have to write the preparation of plaster of Paris, that is calcium sulfate, hemihydrate. Okay. So let us write the preparation of calcium sulfate hemihydrate, that is plaster of Paris. We know that CaSO4, it is plaster of Paris. It is prepared by heating gypsum at 373 Kelvin, that is 100 degrees Celsius. This is gypsum, that is calcium sulfate dihydrate. When you heat this at 373 Kelvin, we get plaster of Paris, and there is a removal of water molecule here. Then we should write the uses. What is the uses of plaster of Paris? There are many uses. It is used in the making of statues and toys, and also it is used to fix the fractured bones or cracks in right position, used in making decorative materials, toys, statues, and also it is used in fix fractured bones in right position. Okay, you might have seen whenever there is accidental fracture, the doctors will wind the plaster that is made up of plaster of Paris, so that after some days the fracture will get recovered and the bones will be in the right position. Yes. This is all about calcium sulfate hemihydrate, that is plaster of Paris. Then also they have asked about sodium bicarbonate. How is it prepared? Third one is sodium bicarbonate. We know that it is prepared by using sodium chloride as raw material. Okay. What happens? The reaction of sodium chloride in the presence of carbon dioxide, water and ammonia, there is a formation of sodium bicarbonate. This is sodium bicarbonate or sodium hydrogen carbonate. We have written its reaction and also we need to write its uses. There are many uses of sodium bicarbonate. Among, let us mention some of them. It is used in the fire extinguishers. We know that when this sodium bicarbonate reacts with acid, there is a formation of carbon dioxide gas there. So in fire extinguisher, this reaction is used where carbon dioxide gas is liberated, and this carbon dioxide gas is helpful in extinguishing the fire. Okay, and also it is, as it is basic in nature, it is used as an antacid. It will neutralize the excess acid in our stomach. Okay, this is all about the preparation and uses of these compounds. Then let us move to the next part. Next question. Yes, the question is explain why an aqueous solution of sodium sulfate is neutral while an aqueous solution of sodium carbonate is basic in nature. We know that the acidic or basic nature of the salts depends on the acid and base which are involved in the neutralization reaction. We know that how sodium sulfate is formed. Sodium sulfate is formed by strong acid and strong base. Neutralization of strong acid and strong base, that is when NaOH and H2SO4 neutralized sodium sulfate is formed. Whereas sodium carbonate is formed by weak acid and strong base. How is it formed? Sodium carbonate, when sodium hydroxide and carbonic acid react, we get sodium bicarbonate. Okay. This is the reaction. In this case, the neutralization reaction is between the strong acid and strong base and strong acid So the resulting salt will be neutral. Whenever there is neutralization reaction between strong acid and strong base, neutral salt is formed. But here the neutralization reaction is between strong base and this carbonic acid is weak acid. So the resulting salt will be basic salt. You have to remember this. Okay. As carbonic acid is weak acid and sodium hydroxide is strong base, the neutralization reaction between them will result in the formation of basic salt, because of which sodium carbonate is basic in nature. Okay, this is all about the PYQs and exemplar questions. So we have covered almost all the questions along with their concepts. So go through all the concepts. Once you go through the concepts, then it will be easier for you to solve the questions. Before solving the questions, keep in mind that you should read the question properly. Okay. By this, let us end this session. In the next session, let us discuss the another chapter.